Hello, everybody. I am actually very disappointed. Just need to get it out. When I knew I was coming to Ancient City in St. Augustine, I thought, that's cool. Ghost town, high-end hotel. Maybe I'll run into like a lifetime hero of mine, but hasn't happened yet. Jokes aside, I'm really happy to be here. I want to thank HashRocket for putting this together. It's always good to hang out with old friends, make new friends, talk to people that are way smarter than I am. Like Micah said, my name is Carlos. I work for Code School. We're kind of down the road in Orlando. We're an online school for learning web technologies, Ruby, Rails, JavaScript, Git. This week, we launched our first SQL course, another free course, Try SQL. So if you want to learn about SQL, if you have a friend that you want to learn, that you want to incentivize to learn about SQL, make sure to check that out. And also, we have a booth here. Christina is hanging out at the booth also with Dan and myself. So if you want to try out Code School, maybe get 2 days for free, make sure to stop by the booth, sign up on our app. We won't spam you, we promise, but you get 2 days for free. And also, I want to ask this question. Does anybody here not work with Ruby full-time? A couple people. All right, cool. So stick around. Later today, Dan is going to be talking about making the transition to sort of like working with Ruby and in a startup environment in a lightning talk. And I know there's companies hiring, so if you'd like to work with Ruby full-time, maybe talk to those companies. HashRocket might be one of them. So there you go. All right, now I want to ask you to try and picture the following situation, which a couple of you might have gone through, hopefully. So this is the perfect Rails web app, right? It met the deadline, so it was live when it was promised that it would be live, and it was developed within the budget, so your team didn't spend any more money than it had to, maybe spent less money than initially thought it would spend. It had all the features that it needed, right? And this might not necessarily mean all the features that the client asked or that he would hope it would be there, but all the features that you all agreed that needed to be there on launch date, right? And it had enough tests. Not too much, not too little, decent test coverage, not too many bugs, everybody's happy. So a perfect Rails web app, right? And it's launched, it's live, you start getting new users into the system, and your client's happy, and then a couple weeks go by, and they go back to you, and they say something like, we need a snappier experience. They're like, snappier experience. And what this typically means is that the client wants to push things a little bit more to the client side. Maybe use some sort of client-side framework like Ember, Angular, React, something like that, and make the website a little snappier, make the UI a little more responsive. Or maybe he'll say something like that. And it's happened, right? So you launch a website with a certain expectation, but it turns out that your users end up using it in a different way than you initially expected, right? In this case, the users are accessing your website through mobile devices rather than through a desktop browser, right? So your client realizes that they need to invest in a native app as soon as possible. This is not bad, this is good, this is a good sign, right? Especially if you follow the agile and lean principles, you embrace change. Change is good, and you adapt to change. So the natural next question is, does our web app expose an API? So can we create a native app that talks back to our original application without forcing us to rewrite or to duplicate things around in our web app, in our original app? And the answer to this question is usually kind of. Because if you think about it, it's almost impossible to write a Rails web app without exposing some sort of API. But is that API good enough to serve different clients? Maybe a JavaScript client at the same time as a native client, at the same time as a command line application, all at the same time from the same API, right? And what I'm going to be talking about today is 5 things that we can do to our app to answer this question. Does our web app expose a web API? With a confident yes, it does. So we can write new clients, new API clients, and simply plug into our existing app without a whole lot of work. So let's jump right into it. First thing, routes. So routes are the entry point to our application, to our API. So the URLs are literally the I on API. They are the interface to our application. And they are extremely important. So good and expressive URLs, they're useful for both developers and for API consumers, because they convey intent and they sort of serve as self-documentation. So let's look at the following example. Suppose we come across a URL for /projects, right? It's intuitive that this URL is going to return a collection of your projects. Suppose that you make authenticated API calls to this URL. You would expect a collection of projects to be returned in the response. And what we also do, we use the URLs to, we add on to these existing root endpoint keywords to filter this result. So if /projects returns all of your projects, then perhaps /projects/archived will only return your archived projects. And in the same manner, you can use an action like archive with an identifier for a specific project to act upon that resource and archive that project, right? So these are examples, very simple, but of intuitive URLs that you don't necessarily need to read a whole lot of documentation so your users, so you understand, or to make it understandable and usable from API consumers. So how do we implement something like that from Rails, right? So this is simple, right? If you've written any sort of Rails application, you've probably written something like that, right? Use the resources, right? Which was added back in Rails 2 point something back in 2006. So resources projects, this one line in your routes file will give you a bunch of things. So we'll give you a bunch of paths that combined with the HTTP, a subset of the HTTP methods will give you all these combinations of controller and actions. The CRUD operations, right? Create, retrieve, update, and delete. So this you get out of the box with that single line. But how about those 2 sort of filtered URLs that we just looked at? What if we wanted /archived or the archive endpoint for one specific project? Well, we can use 2 methods, the collection and the member. So collection, as the name implies, is are endpoints that will act upon the entire projects collection. As opposed to member, it will act on a single. The problem with this is that when people find out that they can do this, they start doing it for everything. So they add onto these blocks, and not only the routes file becomes big, but the real problem behind it is that controllers get super fat, right? Because each of these additional routes translate into a method on that specific controller. So the project's controller now will not only have the 7 default actions, index, show, update, whatnot, but also will get archived, active, suspended, archive, activate, suspend, create view. So that will turn into a huge controller. That's bad. Fixing this, it's sort of easy. All you have to do is add another option to each of these methods, and you can pass in the controller action that you want to direct that specific URL to. So the URL stays the same. We get to keep our expressive URLs, but we get to treat them on specific controllers. So archived, that action, that URL, I'm sorry, is now going to be redirected to the archived projects controller in the index action. The active will be under the active projects controller, suspended projects controller. And then the same thing for archive, activate, suspend. Now you might be thinking, well, but that's way more controllers than I had before. Yes, it is, but you get to work with the default actions for the CRUD operations. And it's not, if you think about it, it's not really hard to think of it as this way. If you want to get a list of archived projects, you're literally listing, a list of archived projects. Like even when you say it, it's like stupid redundant because it makes sense, right? So it helps you to spread out the logic across different controllers when those controllers will have, perhaps this one will just stick with index. So that's a single method in your controller, right? As opposed to, maybe 15 methods on the project controller. So you get to keep your projects controller really clean and focused, and you get to spread your logic around specific controllers. So when you have developers working on something related to the archived projects, it's unlikely that their work is going to conflict with another developer working on some other section of projects. But how about this last one over here, create review? So this one is a good candidate for being extracted into its own resource, right? So resources, reviews. But all we needed was to create reviews. And right now, we're exposing all the different operations. So we can narrow it down to create by using the only create. And when you have a lot of resource definition, when you narrow down, it helps a lot in performance, right? Your app runs faster. Talk about content negotiation. So content negotiation is how the client and the server agree on the best format for a response, right? So you have the same code on your back end, on your server, that will respond at the same time to different clients, maybe in a JSON for one specific application, and XML for another application, and maybe an HTML on a different language for another type of application, all coming from the same code base. So how do we do that? How do we serialize back to our API clients? So the built-in way in Rails is using JBuilder, right? Ships with Rails. It's a dependency that's already in a gem file. Might be commented out, actually. It's a good point. But this is what the syntax looks like, right? And what's good about it, again, is that it's under the Rails organization. I believe one of the maintainers works for HashRocket, might be around here. So it's good. I've used it a couple times. But some people are not really comfortable with the syntax. Another one that's pretty popular is active model serializers, which is a project that's a little bit more object-oriented, allows you to write serializers in a more OO approach. And the syntax actually looks kind of similar to active model. So you can see here, you can use relationships at the serialization level, and you declare your attributes, and you get to do some cool stuff like embed IDs, which help speed up your client side, right? I'm not going to know too much about what this is, but this is really useful if you're, especially if you're using something like Ember.js with a JSON API adapter. It sort of like magically does a bunch of work for you and saves in a lot of additional HTTP calls to the server. And it's a project originally created by Steve Klabnik. Steven he's an amazing dude. He's involved in a lot of different projects, has a lot of commits to Rails, is involved in Rust, and right now this project is going through a major rewrite. So if you want to use active model serializers, you might want to take a moment to read through the docs and see exactly which version works best for you. but it's still good. I've used it quite a lot. And the coolest thing about active model serializers is that it defaults to the JSON API format. JSON API is a MIME type, also created by Steve and a couple of other people, and it's a standard for building APIs in JSON. And what this really means, it's an anti-bike shedding weapon. And the intent of this project was to stop discussion about stupid stuff that doesn't matter and allow you to focus on what's important, right? So JSON API kind of suggests formats for how to return collections, how to return single resources, how to declare the relationship between your resources in your JSON, which is the kind of discussion that people tend to have a lot when there's no single place that they can refer to, right? And people tend to disagree a lot. So if you follow the JSON API format, which now is registered with the IANA, which is sort of an internet standard that takes care of DNS, IP addresses, and a bunch of stuff. So if you follow the JSON API, you can skip all of that discussion and focus on the business logic, right? And another cool thing about it, again, if you use Ember, Ember has the REST adapter, which also follows the JSON API schema. So it's sort of magical. When you drop the JSON API, when you set your Rails application to return the JSON API, to serialize to JSON API, and you have your Ember app using the REST adapter, stuff will just like magically happen, like for real. Cool. Another option is to use a project called Roar. This is the new kid on the block, is the most recent of these, and developed by Apatonic, if that's how you pronounce his name. Yep, got it, cool. And it's a wrapper around another project called Responder. Anyway, this is what the syntax looks like, and it gives you two options. You can either declare your serialization format as a module and mix that in to your own pure Ruby classes in your Rails apps. That's what it looks like, and mix in. This is using the JSON API, which is also supported out of the box. Or you can use a more OO approach and just write a class, right, and extend from Roar decorator, right? And again, you mix in the JSON API, and it works right out of the box. Another cool thing about this is that you can also use it to parse incoming messages. So you can write both the server and the client using Roar. Pretty cool. Now, I want to ask you to try and read this message.
Hello world.
Close. All right, maybe this one. Not missing a semicolon at the end. All right, how about this one? A little bit better, right? So these three mean the same thing, but it's hard to have everybody agreeing or understanding what they mean, right? So when we talk about APIs, we get to use something that's way easier to understand than messages like this. So what if instead of showing you this message, now think, this is in terms of APIs, right? We're talking about HTTP. I told you this. Yeah, right? Way easier to understand. If you work with APIs long enough, or even if you just started, chances are you know that 201 means the request was fulfilled and a new resource was created. So a status code is worth 1,000 words. It's extremely important, right? Before you think about what type of error message or what type of success message you're returning to your client, focus on the status code. Any API client that's worth using or that has been given enough thought into development will first look at the status code of a response to determine what to do next, or whether that response was successful, or if it was a failure, or if it's a redirect, or whatever happened, right? The status code should be your main concern. Another example of using a status code. Now let's look at a recent feature added to Rails 4.2. Suppose we have an endpoint that generates reports. So this takes a post request, generates a report, and when it's done, it returns a 200 response with an empty body. This is what the head method means, right? It will simply return a 200 status code, but with an empty response body. So it's a fast response. The problem here is that the report generation is something that's starting to take a long time. Suppose it takes 20 seconds, right? You don't want to leave that request waiting for 20 seconds while the report is being generated. And the reason why we don't have to return anything here, so think of it if maybe once the report is generated, it's automatically copied to a shared folder in a file system or something like that. We don't have to worry about returning the actual report. We just need to worry about generating it, right? So you return an empty response body, but the problem is that it's taking 20 seconds, and you don't want to leave your clients hanging for those 20 seconds. You want to be able to return the request as soon as possible. And so you want to move that to a background job. And the way to do that in Rails 4.2 is using active job. So you get that code that takes a long time, and you just throw it in the perform method on your active job class. In this case, I'm calling it report job. Using the default queue, and just throwing it in the perform method. Simplest way to do it. Now we go back to our controller, and instead of calling report.generate, we're going to use a report job class and call the method perform later. This will automatically add our job to the queue and return our response to the client as soon as the job is inserted. The job is not ready yet, it's just placed in the queue. Now this is not correct. If you look at it, it's returning a 200. And what a 200 means is that the request was completed. The request was successful. That what you wanted to do, what your client wanted to do when they made that initial request was fulfilled. Which is not totally true because you triggered a job, but that job might not be complete. Whether or not it's complete, you don't know at the time that you made this call. There's actually a better status code that you can use for this situation, which is 202. It means exactly what we're doing. It says it has been accepted for processing, but processing has not been completed yet. So this is important. You want to be able to tell your API clients exactly what is happening on the server, and this helps a lot. Cool. Now, authentication. There are different ways that Rails supports authentication out of the box, but I'm going to talk about one, which is the one that we most commonly use for APIs, which is token-based authentication. A couple good things and benefits that you get from using a token is that you can easily expire them, right? As opposed to reutilizing credentials for a website. If you expire those, then the user can't use the website either. But if you provide a specific token, and for some reason you detect abuse on that token, you can simply stop the token and the user can still have access to the website. Or you can also regenerate it, right? You have a more granular control over the token. You can generate multiple tokens for the user, which might be interesting if the user is providing that token to another third-party service. He can generate a different token for each third-party service, so he can choose whether to shut one down in the future or not. And different access rules can be implemented for different tokens. So he might, want to give different access rules to different API clients. So in general, you have more control when you're using the token-based auth. So how do we provide the token? As API developers, how do we provide the token for the users? It's usually an out-of-band process, which means it's not part of API calls in any means. So the user has to go out of band, has to go to the website, usually the profile page on whatever website, and they'll get the token from there and add it to their application. Hopefully not add it to the version control, like it was mentioned before, and use environment variables. Anybody here use Backpack back in the day? No? 1, 2, no, that's just a camera? Okay. All right, so Backpack used to be a 37 signals, and I just used this because that was the first time that I wrote a Rails API and had to use token auth, so that's always a happy thing to remember. But the service has been discontinued. I don't think you can sign up for it anymore. But anyway, this is an example of how you get an API token to use on API calls to the Backpack API server in this case. So you get it off of their website of your profile and then use it for your clients. So from a Rails side, how do you authenticate someone with the token? Turns out Rails supports it out of the box for us. You simply use this method, authenticate or request with HTTP token, which takes the token as an argument to the block. And then this is your custom authentication method. You can call it whatever you want. You can create your custom stuff. I'm just doing a find by auth token in this case, but you can check for permissions. You can do whatever you want as long as you return something truthy. If you return something truthy, the request will go on, because in this case I'm using a before action. So if a before action, if this method in the before action returns null or false, the response would be a 401 not authorized. So pretty handy method. That's all there is from the controller. Now, again, from an API perspective, how do you generate this token and display it on your user's page? So to generate the token, in this example, we're going to use UUID, which is a universally unique identifier. It's a standard. There's an RFC for it, which means that most clients should be able to support this. So the RFC is kind of like a seal of approval, right? So it's legit. So using the UUID, how do we do that from Ruby? Turns out we don't need any gem. The Ruby standard library offers us a class and a method to generate that for us. So you call UUID on secure random, and it's going to spit out a token that looks like that. And according to the RFC, it's guaranteed to be unique across a global namespace. But if you really want to make sure that it's unique, you might want to create a database constraint just to guarantee that uniqueness. But we're going to skip that for now and just stick with Ruby and Rails. So how do we call that from our application? Simplest example. I'm going to move that into a user model and use that from inside an ActiveRecordCallback. Now, this is one of the very few situations where I personally use an ActiveRecordCallback, because it's only dealing with properties from the class itself. Out there, when we usually see examples of ActiveRecordCallbacks, they're doing crazy things like sending emails, calling out to other web services, and please don't do any of that, right? I'm only using this over here because it's dealing with the user's own properties. So let me go over this code real quick. So before create, set auth token. So set auth token is going to return immediately if the token is present. Why do I do that? First reason is to facilitate testing. If I'm testing and I want to inject a specific token on my tests, on my setup, or on my before, depending on what you use, you might want to inject a custom auth token. And when you create the user, if you inject that token, you're not going to override it, right? So just return. And this is called a guard clause, right? Next, if it's not present, we're going to generate the token, and we call that method that we just saw, but we're going to make it a little more URI friendly or API friendly. We're just going to omit the hyphens. So do a little G sub there. And that's all there is. Another cool thing is how you can test that from curl. So if you use curl, you can use the -h option, which indicates that you're passing a custom request header. And because the token authentication is part of HTTP spec, you can actually see that the header, you can actually see that format from the spec. So this is the format that the token-based auth follows, is the authorization : token, space, token, and then the actual token. So this is what it looks like. And you call that from the command line using curl, and if you get a 200 back, then you're good. If you use the wrong token, or if you omit the token, you would have seen a 401 not authorized response. So pretty cool. If you work with APIs, curl is probably going to be your best friend. Talk about versioning now. First thing that comes to mind when we talk about versioning, and especially open source these days, is called semantic versioning. Now, semantic versioning works great for software and software libraries. Not so great for services. So in a nutshell, semantic versioning, you update the patch when you fix a bug, you update the minor version when you add changes that are backward compatible, and you update major versions when you add changes that break the existing API. Now this is the general rule for semantic versioning. Now versioning services is a little bit different. You want to avoid supporting multiple versions of a service as much as possible, because think of it, when you have multiple versions of a library, it's just there, right? If you throw it up on GitHub, on Bitbucket, whatever, you throw it out there to the world, you don't necessarily have to worry about providing an infrastructure for it, or really, it's not really up, on your shoulders to even support that library. You can just say, hey guys, here's what I've done. I don't have time to work on it anymore, but it's up there, right? That's just a library. But when you're talking about a service, if you have a service, you have to worry about keeping that service up. You have to worry about the infrastructure that supports that service, about monitoring, about performance, about costs. So it's a little bit harder to maintain multiple versions of a service when you compare it to software libraries. So my advice is only use major versions. There really is no need to worry about minor versions or patches when talking about APIs. Focus on changes that cannot break existing clients. This will help you only bump the major versions. So there's no need to bump version on compatible changes. If you add something that's not going to break your existing clients, don't bump the version. There's other ways to let them know about these changes. You can write a blog post. You can send an email to the registered API developers. You can tweet about it, but you don't have to make any changes to the actual version and force all the users to change it, to change their programs just because you change something that might not affect them at all. Example of compatible changes. Maybe you added a new format. Maybe you started with JSON and now you added XML. Why would you bump the version if maybe your clients don't really care about the new format? Just stick with the old one. Or maybe if you add a new property and a resource. Maybe your user model was returning first and last name, and now you added a full name property. Why would you want to force your users to use that new property when first and last name are still going to be around? And also, renaming of an endpoint. We have a status code for that. The 300 class is all about redirecting. So there really is no need, if you think about it, to force your users to change their programs when the changes that you made to your API are backwards compatible. Now, how about when we remove an endpoint? Say we have a / project, and then we remove that endpoint and we don't have it anymore. Raise your hand if you agree that's a backward incompatible change. Okay. Yeah, that's a little tough. I don't think I would do that, but that status code is there. So even if you remove a resource, you can still return a status code to indicate that that resource was removed, and technically, you're don't need to bump your version. I've personally never done that. I don't think I will, but Matt Nottingham, he suggests that on one of his blog posts, and maybe it's just a food for thought, right? Maybe, we went a little bit too far on the status code on this one, but just knowing that it's there, maybe it might be helpful in the future. It's a little too radical for me though. Lastly, I want to talk about tests, how to automate the verification of your APIs. One thing, and the most important thing about testing APIs, this is not the time or place to test business logic. We're not testing the core logic of your app when we're talking about API tests. The place to do that is on unit tests, because they run a lot faster, they're a lot more focused, and they're just the right tool for the job, not API tests. So when talking about APIs, what should we test? A couple of things that I like to focus on API tests: status codes, MIME types, and authentication. How should we test? Just make requests to the endpoint and check the responses. Sort of a black box testing. And the easiest way to do that in Rails is with integration tests. I'm going to show you a couple of examples using a mini test. So no additional framework at all. Super simple, super easy to do, super easy to write. Suppose we want to write a test for listing our projects. If our API is set to run on a namespace or a subdomain, first thing we have to do is call the host method with the subdomain. In this case, I'm using API. Then we issue a GET request to the endpoint /projects and assert for the two things that are most important for us in this case, which is the status code. We need to make sure it's success, 200, and we need to make sure that the response body is not empty. That's it, right? That will get you a long way, right? And if you're doing sort of the outside testing, this is enough to get you to the next level, to the next granular level, right? Might be a controller test, might be a unit test on your models, or you might want to unit test your serializers if you're responding with the complex format, right? I would not test very thoroughly the response format in our integration tests. I like to keep them as simple as possible. Now, testing MIME types. So we want to make sure that our /projects endpoint returns both XML and JSON. And to do that, we use the accept header. So the accept request header at the top is requesting the type to be JSON, and we use this constant that Rails gives us. We don't have to type application/JSON. We can just use the constant. And then we assert that the response that we get back is using that content type, the content type response header. And then the same thing for XML. The accept request header needs to match the content type response header. So you can see it's kind of simple and straightforward. Testing authentication and access rules. So same thing here at the top. We're setting up our host. Make sure that we're using the subdomain. Creating a user. In this case, I chose to just let the token be generated, but I could inject it here if I wanted. And I'm using the authorization request setter. Remember that we saw a moment ago? So the authorization is set to that user token exactly. So this is an authenticated call, and it should return a 200. And I want to make sure that it also returns a JSON MIME type. Now here at the bottom, I'm forcing a fake token. So I'm using the user token, but I'm appending the fake string just to make sure that it's fake. And then I check for a 401 response status. So there's not a whole lot that you need to do on your API, at least to have that sort of safety net that that your API is working as expected on the most crucial things that it needs to do. So status codes, authorization, and MIME types. This is definitely a good place to start. So that's all I had for today, and I want to take a couple of moments just to mention, shameless plug. This is one of our courses at Code School. Talks a little bit about what we talked about here today, but goes also into details of writing APIs in Rails, called Surviving APIs with Rails. So if you want to try some of this out, you can try it in the browser. So the whole point of Code School is that you don't have to download anything in your computer. So if you want to get a taste of what it's like to write APIs in Rails, I suggest you check out this course. And also, we at Code School, we love doing podcasts. So we do the weekly, twice a week, Ruby 5 podcast, and more recently we have also launched a podcast about JavaScript, which is the 5 minutes of JavaScript, and iOS Bytes. All of these podcasts follow the same format, and we love to have people on the show. It's not an interview based, it's a host and co-host, quick paced. Episodes are around 5 minutes, and it takes us around 1 hour between writing the stories, recording the episode, and we don't have to do any editing at all. So it's super fun to do it. So if any of you are interested in helping with any of these podcasts, please send me an email, and I'd love to talk to you. If you have any questions, I'm going to be around here. Feel free to pull me aside. I'd love to talk to you about it, and thank you very much.